is 2. So next question is, in this experiment, question number 2, in this experiment you will identify a straight chain carboxylic acid by titrating an aqueous solution of this acid with aqueous sodium hydroxide. 1 mole of carboxylic acid react with 1 mole of sodium hydroxide. The carboxylic acid contains carbon, hydrogen and oxygen atoms only and has no carbon to carbon double bond. Fb2 is an aqueous solution of the carboxylic acid containing 10.50 gram per dm cube. Fb3 is 0.110 mole per dm cube sodium hydroxide. Fb4 is thermophthalene indicator. Rough, and you know that the thermophthalene indicator color in acid is colorless and in alkali it is blue. So this is rough titration. Final burette reading is 24.00. Initial burette reading Fb3 centimeter cube. This is centimeter cube, not gram. This is centimeter cube. The unit is centimeter cube. 24 and initial is 0.00. Volume of Fb2 used is 24.00. The rough titer is 24.00 centimeter cube. Carry out as many accurate titration as you think necessary to obtain consistent results. Make sure any recorded result show the precision of your practical work. Record in a suitable form below all your burette readings and volume of Fb3 added in each accurate titration. This is the table of accurate titration. Accurate titration. This is first reading and this is second reading. Final burette reading of Fb3 centimeter cube is first reading is 23 and initial burette reading of first is 0.00 centimeter cube, 0.00, and by subtracting initial from final we get 23 centimeter cube. Similarly, second reading is initial reading is 23 and final reading is 46.00 and the final reading is volume used is at 23.00. So these two are best titration, and in consistent result or in best titration there is the difference between two concordant reading is not more than 0.1 to 0.2. 23.00 plus 23.00 divided by 2. This is how to calculate the average burette reading. We get 23. Calculate the amount in mole of sodium hydroxide present in the volume of Fb3 calculated. Mole, we know the concentration of sodium hydroxide is 0.110 and the volume used is 23 divided by 1000. The amount of sodium hydroxide is 2.53 into 10 raised per 2 minus 3 mole. Use your answer to C1 and information on page 2 to calculate the relative formula mass of the carboxylic acid in Fb2. We have 1:1 ratio given over here. 1 mole of carboxylic acid react with 1 mole of sodium hydroxide. By using 1:1 ratio, we have mole of carboxylic acid 2.53 into 10 raised per 2 minus 3. So first, because mass is in gram per dm cube, so the mole should be in gram per dm cube. So by calculating the concentration of sodium hydroxide, 22.53 into 10 raised per 2 minus 3 divided by 25 into 1000. So this is the mole per dm cube, 0.102 mole per dm cube. So calculating MR, so this is mole per dm cube and this is gram per dm cube. So we can calculate MR, mole, gram per dm cube divided by mole per dm cube. So gram per dm cube of carboxylic acid used in this experiment is 10.5 and mole per dm cube is 0.102. We have 102.9, which is approximately equal to 103. So identify the carboxylic acid in FB2, draw its skeletal formula. CnH2n plus 1 plus CO2H. So 12n plus 2n plus 1 plus 45, this is equal to 103, and 14n plus 46 is equal to 103, and is in this way we can calculate the number of carbon atom present in the carboxylic acid. So n is equal to 4. So 4 carbon atom, if 4 carbon atom in carboxylic acid, the name is butanoic acid, and this is the skeletal formula of the butanoic acid. This is molecular formula of butanoic acid, and this is the derived formula of butanoic acid. A student carries out a similar titration to the titration you carried out in A. The only difference is that a solution of amino ethanoic acid is this, containing 10.50 gram per dm cube is used instead of the acid in FP2. Construct an equation for the reaction taking place in the student's titration. Include state symbol. So this is the chemical equation for this reaction. Amino ethanoic acid plus sodium hydroxide to form amino sodium ethanoate plus water. So student state whether the student's titer will be larger or smaller than your titer. Explain your answer. The student's titer will be lower than mine because MR of amino acid is 75, which is lower than MR of FB2. So more moles of amino acid is used. So this is all about of question number 1 and 2. Hopefully you understood. If you understood, please like the video and subscribe the channel.